Good day, everyone. My name is Irvin Lopez, and today I will be presenting my oral progress report for my engineering management project titled Enhancing Field Issue Resolution Workflow for Compressor Components. This project focuses on improving how compressor field issues are investigated, documented, and closed within aerospace operations. The main objective of this project is to improve the overall effectiveness and speed of compressor field investigation. Specifically, the project aims to reduce investigation and closure times, improve the quality of initial technical data, standardize communication across teams, and increase visibility into investigation progress. These improvements are important because delayed investigations impact customer confidence, operational availability, and internal engineering efficiency. This project follows a structured timeline from December 2025 throughout February 2026. So far, the baseline review phase has been completed, sprint planning is currently finishing, and sprint 1 is about to begin. The project is organized using an agile style approach with two major sprints followed by validation and final integration. Here you can see the high-level project schedule. The first 2 weeks were dedicated to the baseline review. The following 2 weeks, sprint planning. The next 2 weeks, sprint number 1. Weeks 7 to 9, sprint 2. And the last 2 weeks for validation and integration, followed by the final presentation, which is scheduled for February 11. This structure allows improvements to be tested incrementally instead of implementing everything at once. Sprint 1 focuses on data quality and intake standardization. The main activities include defining mandatory intake data such as photos, dimensions, damage location, environment, and maintenance history, creating an investigation intake checklist, developing and standardized damage documentation template, creating a standard investigation case form, defining case classification rules, and piloting the checklist using one historical investigation. The idea is to fix problems at the very beginning of the process so downstream engineering work becomes more efficient. Sprint number 2 focuses on speed and visibility. Plan improvement includes redesigning the workflow to allow parallel engineering reviews, defining engineering turnaround targets, integrating quality earlier in the process, designing a Kanban board to track investigations, creating an investigation dashboard template, defining standard communication templates, and finalizing the future state workflow map. Together, these changes target the main causes of long investigation cycles. During the baseline review, multiple past compressor investigations were analyzed. One key result was identifying that closure time often spans several months, in some cases extending significantly beyond initial expectations. This confirmed that the current process is functional but inefficient and inconsistent. This chart shows baseline closure times for the four recent investigations: 3, 4.5, 5, and 6 months. The average is about 4.6 months, with noticeable variation. This confirms there is significant opportunity to reduce cycle time by eliminating rework and improving coordination. Several recurring delays sources were identified: incomplete or poor quality technical initial technical data, repeated data requests between teams, sequential handoffs between engineering disciplines, late involvement of quality and safety, and lack of centralized task visibility. These delays compound over time and significantly increase investigation duration. This slide shows the current workflow. The process begins when an event occurs in service and an incident report is created. Then, a case is opened, hardware and data are requested, preliminary technical reviews are performed, detailed assessment follows, safety and compliance reviews occur, customer review is held, and finally the report is issued and the case gets closed. While structured, the workflow is heavily sequential and involves multiple handoffs between operators, field support, engineering, quality management, and also customers. Key limitations of the current process include sequential handoffs between teams, repeated data collection cycles, engineering reviews happening mostly one after another, quality and safety being involved too late, and limited real-time visibility into task status. These factors contribute directly to longer investigation times and coordination challenges. Stakeholder interviews confirm these findings. Engineering teams, field support, and quality personnel consistently reported frustration with missing data, unclear ownership of tasks, and difficulty tracking investigation progress. This feedback strongly supports the need for process redesign. During the baseline phase, a few challenges were encountered: incomplete technical documentation in older cases, scheduling delays for interviews, and coordination challenges across multiple disciplines. As a result, the baseline review extended slightly into early January, but the overall project timeline remains intact. From the baseline analysis, several early improvement ideas were identified: standardized intake checklists, mandatory photo and measurement requirements, parallel review structures, visual tracking tools like Kanban boards, and defined response time targets. These ideas directly shaped Sprint 1 and Sprint 2 planning. Currently, the baseline review phase is 100% complete. Sprint planning is being finalized. Sprint 1 is ready to begin. The project is on schedule and no budget impacts have been identified so far. In conclusion, this project addresses a real operational problem: long and inconsistent compressor investigation cycles. The baseline review has confirmed where delays occur and why. The upcoming sprints will focus on improving data quality, increasing speed, and providing better visibility throughout standardized tools and workflows. Thank you for your time, and I welcome any questions. Have a great rest of your day. Thank you.